Now, we have over 400 factories across our supply chain just within GE, and tens of thousands of suppliers. And when I visit those factories, the pride in the workers in what they do can never, ever, ever be replaced. And I don't want to replace it because they have a knowledge and a feel. And how do we harness that? And how do we give them more to feel and touch and learn and give us feedback? This is the future of manufacturing. It's really about being all in. Why do I believe in this? Why am I passionate about it? Well, we did start on this journey a number of years ago with a component that we make for aircraft engine. It's a polymer matrix composite. It's a very complex material system. It makes a fan blade, which is about 3 feet in length. You can see the shape of it, twists, tolerances. It's got a metallic sleeve that goes over the front so that it's very durable in the field. It's very difficult to make. We make it in a number of factories here in the United States across GE. And we put in this concept of a brilliant factory because it was hard to do and we had very low first-time yields, 20% or less when we introduced a new design because we just didn't know. But we started putting sensors in. We started understanding variability of material. We started understanding different fiber strengths and how the machines that did the layup for composites responded to it. We started getting this producibility data and feeding it back to our designers. So as they changed design, improved design, made new design, they understood what we can do. We collected the data and built the physics models to do virtual manufacturing. So as we designed a new part, we could simulate it before we ever made a tool, ever ordered a material, so that we were better and faster and more iterative. And we involved everybody in this whole digital thread chain. We put in automation, but that doesn't mean robotics. Automation here meant being able to get the feedback, respond to it through our control system, and make a change, both with humans and with some automated equipment. And what are we doing now when we introduce a new design? Instead of 20% first-time yield, it's over 95%. This is real. It makes a difference. And as we look at all the new technologies that you see outside these doors, how are we going to introduce them? How are we going to make sure that we teach people? How are we going to make sure that we can use it to its fullest extent? We have to have this vision together. We have to work together to build these ecosystems. We have to be able to think about digital plus physical. So as we're thinking about it, we're working with a number of different companies and institutes, from software to physical hardware to tooling. We're working with the National Network of Manufacturing Institutes, specifically the Digital Manufacturing Institute, to be able to build new platforms where we can share data. We're using some of our software called Predix, which is a platform that you can think of putting applications on top of. And the application may be a factory flow model. The application may be the feedback from the sensor. The application may be a virtual manufacturing model. And there's lots of great software out there and lots of great partners. And we're building ways that we can communicate and try things out and collaborate without anyone worrying about their IP. Because we can code it and we can challenge and we can learn together. This is about the future of manufacturing. This is about exponential change. This is about us being together as a community to drive digital plus physical, change in a day, and exponential growth. Thank you.